All right, welcome back, everybody, to CLT Math Crash Course. This is day 2. We're on part 2. We've got Karis with us still, and we are practicing the strategy of plugging in values in place of the variables to solve these questions here on the CLT. We got a new question up on the screen. This is question 117. Go ahead and read this for us, please, Kara.
If negative p to the third power is a negative even integer and p to the q power equals 1, then which of the following would describe q over p minus p to the 16th power?
Oh my goodness, there's so much going on here, this question. So much. So much. I don't even want to start with the algebra on this. I don't even want to think about it. Let's do what we've been doing. Let's plug in values in place of the variables, okay? Let's create a value for p. Let's create a value for p, okay? P, they tell us here, or negative p to the power of 3 at the very least, is a negative even integer. So we need to create a value for p that's going to give us a negative even integer for negative p to the power of 3. Does that make sense?
Yes.
Okay. Okay. Can you think of any values here that we could plug in for p?
Oh boy.
Yeah. And we can test things. Like, don't feel like you've got to just pick the perfect value right off the bat. Like, go with something and let's try it. And if it doesn't work, we'll try something else.
So I'm trying to think of a number that would still be even.
Yes, it's got to be even.
Even to the power of
right. So we can't
3.
we can't plug in a 1 here. That's not going to work.
Right. Would a 2 work?
I think 2 would work. Let's test it. Okay? And this is the way I want you to look at this question. Like, don't be afraid of making mistakes. Like, just all these questions, especially when we're plugging values, it's just a series of experiments. There we go. Okay, so let me see you plug in a 2 for p into this expression. Let's see what we get.
Okay.
Yeah, negative 8, absolutely, right? 2 to the power of 3 is 8, and we got to make it negative. Even if the negative sign were inside the parentheses, I think we'd get a negative number here, but it doesn't matter here. It's going to be negative 8. Is that a negative even integer, Karis?
Yes.
Yes, it is. I think 2 works for p. Does that make sense?
Yep.
Okay, good. All right, so we'll keep that for right now. So p is going to be 2. And then notice, let's look at the second part here of the question, where it says p to the power of q equals 1. Oh no, right? Now, I mean, if we plugged in a 1 for p, we could pick anything for q and it would work. But remember, we can't plug in a 1 for p because it wouldn't give us a negative even integer. Right? So we got to come up with a value for q that's going to give us a 0. It's going to give us a 1 when we raise 2 to the power of q. Do you know what q is going to have to be? I know what it's going to have to be. Maybe some students watching the recording know right now. I know exactly what q is going to have to be. Yeah.
It would have to be 0, right?
It's got to be 0. Absolutely. Absolutely. And I think I've got this on the Basic Concept Study Guide as well. Let's go to that real quick.
Okay.
Properties of exponents. This is Basic Concept E. Basic Concept E. So go to that first bullet point on Basic Concept E and read that for me. This is helpful to know.
Anything to the power of 0 equals 1.
Anything to the power of 0 equals 1. Okay. Have you studied that before, I take it?
Yes.
Yeah. This trips up a lot of students, right? A lot of students think things to the power of 0 equals 0. Anything times 0 is 0, but anything to the power of 0 equals 1. Do you know why that's the case, Karis? Have you learned that before?
No.
No?
I just had to know that that's what it was.
Yeah. I remember as a student, asking a math teacher this. I was like, why is anything to the power of 0 equal 1? It doesn't make any sense to me. I didn't quite get it. And the teacher's like, just memorize it, just remember it. And I'm like, okay. And that was it. But I understand it now. Do you mind if I share with you why things to the power of 0?
Yeah, go right ahead.
Yeah, okay. So I'm here on the whiteboard. I'm just below. And again, this doesn't directly relate to the question other than the fact that I'm explaining why things to the power of 0 equal 1. But let's start with an expression like x to the power of 5 over x to the power of 3. Do you know what that equals?
That would be x to the power of 2?
Yeah, it's x to the power of 2. Okay, and there's a couple ways to think about this. You can just be like, oh, I've got x multiplied by itself 5 times in the numerator, x multiplied by itself 3 times in the denominator. 3 of them are going to cancel out. I'm just left with 2 x's, right? That's going to give me x squared. That's one way to think about it. There's another way to think about it too, and I'm guessing this is how you did it. If you have a like base, which we have here in x, right? We've got x in the numerator, x in the denominator. This wouldn't work what we're about to do if it was x to the power of 5 over y to the power of 3. But because we've got a like base in x, we can do this. We can take the exponent from the denominator, bring it up to the numerator, and subtract it. You seen that before?
Yes.
Yeah. So we get x to the power of 5 minus 3, but 5 minus 3 is 2, so it's just x to the power of 2. Does that all make sense?
It does, yes.
Okay, good. Okay. Let me show you another expression here. I'm just going to modify the one we've got. What's x to the power of 5 over x to the power of 5? What's that equal?
That would be x to the power of 0.
It's going to be x to the power of 0, right? Because we're going to do that same operation, right? We've got a like base in x. Take the exponent from the denominator, bring it up to the numerator, and subtract it. We get x to the power of 5 minus 5, right? 5 minus 5 is 0, so it's x to the power of 0. But x to the power of 0 is 1, and that makes so much sense now, I hope, because anything divided by itself, which is what we have right here, anything divided by itself is 1. So if you see anything raised to the power of 0, Karis, what it really means is it means it's being divided by itself. Does that make sense?
Yes, interesting.
Isn't that
okay.
interesting?
Huh, I've never heard it explained that way
I know,
before.
right? Neither have I. I had to figure this out on my own. But when I did, I was like, oh, it makes so much sense. I'm sure there's teachers out there teaching. I hope. I don't know. But like you, as a math student, right, it was just like, just know that anything to the power of 0 is 1. Okay. Right? But that's why it works. It means it's being divided by itself. Okay? And anything divided by itself is 1. Okay. All right. Helpful to know here, I think, on this question, at least that anything to the power of 0 is 1, and that's the case. So Q has to be 0. It has to be. Now, it could be, and Q could be 2 or 3 or 4 or 5 if P were 1, but we know P can't be 1, right? Because if P is 1, we don't get a negative even integer. We'd get a negative odd integer. Does that make sense why P can't be 1 here?
Yes.
And because P can't be 1, Q's got to be 0. All right, great. We've satisfied the requirements of the question with these values. It works. Okay. Now we got to see which of the following would describe Q divided by P, oh good heavens, minus P to the power of 16. So let me see you plug in those values. It looks scary, but I don't think it's going to be too bad.
Okay.
Let me see you plug those in. We'll see what we get. Okay, so we got 0 divided by 2 minus 2 to the power of 16. Let's start with that 0 divided by 2. What's 0 divided by 2 going to be?
That would have to be 0.
It's going to be 0. So we get 0 minus 2 to the power of 16. Now here, let's use some basic logic. Okay, I don't want to calculate what 2 to the power of 16 is. I don't want to deal with that. Okay, I don't want to. It's going to be a big number. Okay. I'm looking at the answer choices, though, and they want us to know if it's going to be even or odd. So here's my question first. Is that going to be even, or is that going to be odd?
It would have to be even.
It's got to be even, right? Does that make sense?
Yes.
Well, it's got to be even, right? We're just taking 2 and just multiply. I mean, I think anything multiplied by 2 is going to be even. And here we've got 2 multiplied by itself 16 times. It's going to be even. It's going to be some multiple of 2. Okay? Does that make sense?
Yes.
And just knowing that, we can get rid of 2 answer choices. What 2 answer choices can we get rid of?
The C and D. They both have odd.
Absolutely. Does that make sense?
Yes.
Always use that basic logic if you can. With, sometimes you don't have to carry out the specific calculation. I've seen it quite a bit on the CLT. They've got, you can't use a calculator here. It stinks, right? You've got to do some long division and some multiplication with decimals and stuff like that. But sometimes, you can find the right answer without doing the calculation if you use basic common sense and focusing on what you know. You know that's got to be even. So C and D are gone. Now here's the next question. Is this going to be negative or is it going to be positive?
It would have to be negative.
It's going to be negative. It's going to be negative, right? Now you might be like, but aren't you raising negative 2 to the power of 16, right? And you're really not here, right? You're subtracting 2 to the power of 16. Let me give you an example with some other specific numbers. What if we have 1 minus 2 to the power of 3, right? Those are easier values to deal with. What's that going to equal?
that would be 1 minus 8.
It's 1 minus 8, right? Which is going to be negative 7. Does that make sense?
Okay. Yes.
Yeah, you're not, and even if it were an even number, in fact, let's do that. Let's do 1 minus 2 to the power of 2. What is that? That's 1 minus 4, right? You're raising 2 to the power of 2. You're not raising negative 2 to the power of 2. You're raising 2 to the power of 2. Does that make sense?
Yes.
So that's going to be negative 3. It's going to be negative, for sure. So we know this is going to be negative as well. That would be different, by the way, if we were doing 1 plus negative 2 in parentheses. The parentheses here are important. To the power of 2. That would be different, because that would be negative 2 in parentheses to the power of 2. That is going to be positive 4. So that would be 1 plus 4. That would be 5. Do you see the difference here? Where the negative is not in parentheses here. It's not.
Okay.
So what we're raising to the power of 16 is just the 2. Make sense?
Yes.
So pay close attention to the parentheses. Or the lack of parentheses, as this is the case here. Okay. All right. So I don't know what 2 to the power of 16 is, but I know that this statement right here is going to be negative. What's the right answer here?
It would have to be A.
Answer choice A. Bingo. Any questions about that?
Nope.
Okay. Tough looking question. Question.
Yeah, they made it look scary.
They really do. They really do. But I'm telling you, if they give you variables like this in a question, I mean, you see these all the time, which is true, which has to be true. The vast majority of the time, just plug in values for the variables and you got it. Okay. Let's keep rolling. Okay. Oh, let's try this guy. Question 93. Go and read question 93 for us, please.
If x and y are integers and x plus y is a positive odd integer, then which of the following must be true?
Okay. This should be a little bit familiar, the style of question now, right? Which has to be true, right? Not which can be true, which has to be true. It's got to work for all values that meet the requirements of this question. Let's do what we've been doing. Let's plug in values for the variables here. I need a value for x and I need a value for y. But and we can pick anything here as long as x and y is a positive odd integer. We can pick anything.
Let's do x is 2 and y is 3.
We can do it. You could do 1 and 2 here as well. That would work.
Okay.
We'll start with 2 and 3. Okay. Let's test these answer choices. Go and read answer choice. Read answer choice A for me.
Both x and y are odd integers.
Does that have to be true?
No.
No, that doesn't have to be true.
Well, that can't be true, can it?
Can it be true? I don't know. I'm not sure. I'm trying to think of... I'm trying to think of odd integers, but I can't think of 2 odd integers added together. That would give me an odd integer. Maybe there are. I can't think of any. Do you know what I'm saying?
Yeah.
Yeah. I mean, it's not true here.
Okay.
These values, and that's good enough, right? I mean, x plus y here is 5, right? It's a positive odd integer. We've met the requirements of the question. So if A isn't true for the values we picked, it can't be the right answer. Does that make sense?
Okay.
If it were true, we'd keep it. We wouldn't necessarily know it's the right answer. If it were true, we'd keep it. We'd try to get rid of the others. But because it's not true, we can get rid of it. Make sense?
Yes.
A is gone. Let's try answer choice B. Go and read answer choice B for me, please.
Okay, sorry. X minus y is a positive integer.
Okay. Is x minus y a positive integer?
Not in our... Wait. No.
No, because what's x minus y? I mean, it's going to be...
It would be -1.
2 minus 3, yeah, it's -1. It's not even positive. It's negative. So it can't be B. Does that make sense?
Yes.
Okay. Let's try answer choice C.
The product of x and y is an odd integer.
Ooh, let's talk about that term product. You've seen that before?
Yes.
What does product mean?
Multiply.
You're multiplying them, absolutely. Well, it's 2 times 3.
6.
2 times 3 is 6. Is that an odd integer?
Nope.
No, that's even. So it can't be C. Does that make sense?
Yes.
Okay. I think we found our answer. It's D.
That almost seemed too easy.
That did, right? It worked out really, really nicely for those values. Really nicely. Is it possible another set of values would give you, a true statement for another answer choice? Possibly. I'm trying to think of any that would. I don't know. I can't think of any right now that would. But that worked. I wouldn't even know how to begin to do this, like thinking in algebraic terms with variables. I wouldn't even know. But just plug in the values. You can figure it out. It's D. Does that make sense?
Yes.
Elimination is your best friend on this test. It's your best friend, right? You don't have to logically figure out that none of the above are true. You don't have to. That's tough to confirm. But if I know A doesn't work and B doesn't work and C doesn't work, I know it's got to be D. That's good enough for me. Make sense?
Yep.
Awesome. Great job there. Great job. All right. So we're rock and roll. Okay. Let's try this guy. All right, go ahead and read 86 for me, please.
If a plus b is a positive even integer and negative b squared is negative, then which of the following would describe AB?
Oh, this is a tough question. But we got a shot at it. If we plug in values for the variables, so let's do it. I need values for A and B here. A plus B has to be a positive integer, and negative b squared has to be negative.
So we could do 2 for both A and B, right?
I don't see any reason why not. Yeah, let's do it. Let's try it.
Okay.
So we'll make A2, and we'll make B2. Okay, so is A plus B a positive integer? We'll test that first part.
Yes.
Yeah, because we get 4 when we add 2 and 2. So that works. Is negative b squared negative?
Yes, because there are no parentheses.
There are absolutely. I love it. And that would be different from if they said parentheses negative b squared. That would be positive. Because negative 2 times negative 2 would be positive 4. But they don't do that. This is negative b squared, so that means negative 2 to the power of 2. You're just raising the 2 to the power of 2 and making it negative. Make sense?
Yes.
Okay, so this works so far. Okay, I don't know if we're going to be able to find the right answer with these values, but we can start getting rid of some bad ones. Okay, let's look at answer choice A. Go ahead and read that for me, please.
A positive even integer.
Okay, right, and the question is, what describes A times B? So is A times B a positive even integer?
It would be, yes.
It would be. It's 4, right? So let's keep it. Absolutely. What about answer choice B?
It would not be negative.
Nope, it's not negative here, so it doesn't have to be true. So B is gone. What about C?
It can't be odd either.
It can't be odd, right? At least it's not odd here. So it doesn't have to be true. And then go to read D for me.
It is impossible to determine from the given information.
Oh, this is my least favorite answer choice. This is my least favorite, Karis. Because here we got to do some thinking. Okay? Because I can't get rid of D. We can't. Right? Yeah, A gave us a true statement. But if there's some set of values for A and B that wouldn't give us a positive even integer, right? Then it could be D. Does that make sense?
Yes.
So we've got to do some detective work here. We can't just pick... Look, if you got a 50-50 shot. We know it's not B or C. It's either A or D. But I don't think we have to stop there. Let's see if we can come up with some values for A and B that would give us, an AB value that's not a positive even integer. Can you think of any?
Oh boy. So are you just asking for values right now?
Yeah, values for A and B. I want to make that
Okay.
somehow not a positive even integer. A times B, right? Let's see if we can make it. Can we make A times B negative somehow for some values of A and B? Does that make sense?
Yeah, so we could try -2 for 1.
Uh-huh. For A?
Sure.
Yeah. -2 for A. I love it.
But then part of the criteria is that A plus B has to be positive even.
I love where you're going. I love where you're going with this. So what's B? What value for B would give us a positive even integer? You got this.
Would +4
That's what
work?
I'm thinking. That's what I'm thinking. 4. Positive 4. Right? Because what's A plus B? If A is -2 and B is 4.
Then it'd be +2.
Then A plus B is going to be positive 2, which is a positive even integer. We've satisfied that. Now let's double check here the second part. Right? Is -b squared going to be negative when B is 4?
Yes.
Absolutely still, right? Because of the parentheses issue. It's going to be -16. Absolutely. Okay? Now, what's A times B for these values?
That would be the -2 times 4.
Correct. Which is what?
So -8.
-8. Interesting. Do you see that?
Yes.
Do you see that? That's tricky. This is where, whenever you see an answer choice like D, it's impossible to determine. You've got to do some detective work. You've got to do some detective work. You've got to see if you can come up with some values that don't meet those criteria in the other answer choices. And we found values that don't give us a true statement for answer choice A. We found a way to make AB negative. That still meets the criteria of the question. So A is gone. It's D. Any questions about that?
Nope.
I see it pretty commonly as an answer choice. I would take it very seriously. I'm not saying it's always going to be correct. Sometimes it's not. But I'll tell you right now, Karis, it's often correct. It is. It is. And whenever you see it, you should seriously consider it. Seriously consider it. But do you see how we were able to test it?
Yes.
Yeah. Yeah.
So is testing a negative number typically a good idea as well?
You have to here. I think you have to here. Yeah. You have to here. I mean, I wonder if we plugged in like a 3 and a 3, that would have worked, I think, right? To get rid of answer choice A. Does that make sense?
Yes.
We made A3 and B3, right? 3 plus 3 would be a positive even integer, right? That would be 6. And then -3 squared would be negative, right? That would be. So we didn't have to make it negative here. There we would find out, of course, AB then would be 9. Does that make sense?
Yes.
Yeah. Which is not even. So there's multiple ways to test it. Multiple ways. Probably the negative was the easier way. That's what we started with. But this works too. We found a way to make it not even. Questions? Great question. Any other questions?
No, I don't think so.
Tough one. Tough one. But I would, if I see that, I would stop and give it serious consideration. I would. And it worked out here. Tough question. Okay. I think I've got some easier ones here coming up. Give us a little break. Oh, yeah. There we go. This is funny. I've seen a question like this on almost every CLT practice test I've done. These are really funny. I call these weird symbol questions, because whenever you see a weird symbol in the question like we see here, I don't even know what to call it, by the way, that thing. I don't know if it's a Greek letter. I don't know if it's, I don't even know what that is, right? It looks like a wagon wheel. Do you see that in question 87?
Yes.
I literally just read it with students. I read it as weird symbol. So if weird symbol is defined such that, right, just read it like that. That's good enough. It looks scary. It looks complicated. It's not. It's just plugging in values. I'll show you what I mean here. Go ahead and read 87 for me, please.
Okay. If weird symbol
Yes.
is defined such that P weird symbol Q equals P to the third power over Q plus 5, then which of the following is equivalent to 3 weird symbol 9?
I love it. I love it, right? I don't want you wasting time in this test being like trying to figure out what the weird symbol is and naming it correctly. Just call it weird symbol and you'll be good. I've got a section here on the basic concept study guide I want you to check out. This is basic concept F. Basic concept F. I just call it weird symbol operations. Okay, we've got another weird symbol. This is going to pop up on some other questions here coming up. But again, I generally see one of these on each of the CLT practice tests, so I'd expect you to see these on the test you're taking. Go ahead and read that bullet point for weird symbol operations.
Okay. For M, weird symbol
Yes.
N equals 2M plus N over 3, then for weird symbol 3 equals 2 times 4 plus 3 over 3 equals 9. Just plug in the values for the variables.
Do you see what I've done there in that second equation here? I've literally just replaced the M, right, in front of the weird symbol with a 4. And then the N comes after the weird symbol, right? So plug in the value after the weird symbol. That's a 3. So in the expression in that bullet point, right, I've just plugged in a 4 for M, and I've just plugged in a 3 for N. That's all I've done. That's all I've done. Does that make sense?
Yes.
It's literally just a plugging in values question is all it is in a really complicated way. I'm sure there's like some good math reason and maybe some even like fancy math term for this kind of operation. I don't know what it is. I don't really care. Just know this is the operation they want you to do, and it's just plugging in values operation. Does that make sense? All right. So let's do that here. Yeah.
And they give you the values, right?
They give you the values. Absolutely. So what's our P value?
That would be 3.
P is going to be 3, right? That's what comes before the weird symbol. And then what's our Q value?
9.
Our Q value is 9. You're just plugging it in, and then it's just arithmetic. Does that make sense?
Yes.
Is this a question you would have known how to solve previously or no?
Yes, but it took a lot of studying to get there.
Yeah, it's not bad, right? You're just plugging in values for the variables here, and they give you the values. So just plug it in. Let's practice it. It's good practice with arithmetic. So plug in that 3 for P and plug in the 9 for Q. Let's see what happens. Looking good. I'm going to fix that real quick just to make it really clear.
I'm so sorry.
Oh, you're good. I just want to make it clear for anybody watching the recording there. Okay. Let's simplify this. Do you know where to start when we're simplifying this?
I would start with the exponent.
It's PEMDAS again, right? There's no parentheses here, so let's jump right to the exponents. So 3 to the power of 3 is what?
9.
Stop. 3 to the power of 2 is 9.
That would be 27.
27, yes. 3 times 3 times 3, 27. Okay, excellent. And we're still doing PEMDAS here, right? So we got parentheses, exponents are done. There's no multiplication here, but we have division. So let's do the division here. What's 27 divided by 9?
That would be 3.
That's 3. There we go. I think we got our answer. Answer choice C. Any questions about that?
Nope.
Be so happy when you see a question like this on the CLT. Be so happy. They're so easy. They're so easy. It's just arithmetic. It's just arithmetic. Just plug it in. Okay? Okay. Let's do a couple more. And really the difficulty level on a question like this is just how difficult the arithmetic operation is. That's it. Some get a little more complicated. This one's pretty easy. Go to read number 110 for us, please.
If weird symbol is defined such that a weird symbol b equals 2a squared plus 3b, what is 4 weird symbol 2?
There you go. You know what to do here. You know what to do here. What are we plugging in for A?
4.
Plugging in a 4. What are we plugging in for B?
2.
Plugging in a 2. That's it. Good. Let me see you do that. Let's see what we get. Looking good. It's PEMDAS again, right? We've got to do the exponents first. Yeah. Just pops up all the time. And again, I'll have that added to the basic concept study guide. Looking good, looking good. There we go. Easy, easy. Any questions about that?
Nope.
Okay, awesome. These questions are a gift. Just a gift. I think I've got one more weird symbol question. Go and read 91 for me, please.
If weird symbol is defined such that m weird symbol n equals m over 3 plus 2n squared, then which of the following is equivalent to 3 weird symbol a squared?
Now this is a little bit different here. This is a little bit different. What are we plugging in for the m value into this expression?
3.
We're plugging in 3. And then what are we plugging in for the n value?
A squared.
A squared. This is where this one gets a little bit trickier. Okay? A little bit trickier. But it's still the same process. Right? Okay. Plug in that 3 for m. And then we'll plug in a squared for n. Okay? Let me see you do that. Excellent. Love it. Love it. Now I'm going to stop you real quick for anybody watching the recording that might be confused about this. We're not plugging in a in place of n. We're not. We're plugging in a squared in place of n, which means we're going to have to take a squared and raise a squared to the power of 2, like you did here. Beautiful. Perfect job. Does that make sense?
Yes.
You're not just replacing n squared with a squared. You're not. You're not. You're plugging in a squared for n. So you're going to have to square a squared, which you did. 3 over 3 is easy. What's 3 over 3?
That would be 1.
That's just 1. So it's 1 plus. Now this part's trickier here. What do we do? What do we do?
So an exponent raised to an exponent, you multiply the exponents, right?
That's the operation. Absolutely. That's the operation. Yeah. I still wouldn't worry too much about operations. Just think about what this thing means. Think about what that means. What does it mean to raise something to the power of 2? What's it mean?
So it'd be a squared times a squared.
Yeah, it means a squared times a squared. It's the thing is multiplied by itself. That's what it means. So it's a squared times a squared. But of course, a squared just means a times a, right? Right? A squared?
Yes.
Yeah. Times a times a. Right?
Okay.
Which equals what?
a to the fourth power.
A to the fourth power. Right. Don't get me wrong. Like, you know the operation here, and you seem pretty comfortable with exponents, so that's great. I work with a lot of students that just aren't. And I'll be honest, like, I get mixed up on operations with exponents all the time. All the time. I've got to remind myself what the operation is. I don't have the list of rules memorized. I don't. But I'm not worried about it because I know what the notation means. I know what the notation means. And even if you don't remember what the exact operation is, you can figure out what the operation is when you understand what the notation means. You know, if it were more complicated, if it were like a squared to the power of 3, right? A lot of students are like, oh, what do I do there? Do I multiply them? Do I add them? It's one of those things I can't remember. And then they just take a guess, right? Don't do that. Think about what the notation means. That means a squared times a squared times a squared. But of course, a squared means a times a. So times a times a times a times a. Okay, a multiplied by itself 6 times, that's a to the power of 6. So I can actually use understanding the notation to find out what the operation is in case you forget. Oh, clearly I have to multiply them. Okay, great. And that's the operation. You don't even have to have the operations memorized if you understand what the notation means. Does that make sense, Karis?
Yes.
It's a better way to think about it, I think. But you're right. Again, you knew it. You're going to have to multiply those exponents when you raise a power to a power. That's correct. Okay, so let's simplify this. What does that give us, by the way?
So then that would be 2a to the fourth power.
Absolutely. Absolutely. 2 times a to the fourth power. Yeah. Remember, we're only squaring the a squared. We're not squaring the 2. We're only squaring the a squared. You see the answer here, right?
Yes,
Yeah.
D.
There we go. Any questions about that?
Nope.
Okay, great. We'll spend a little more time with operations with exponents. That is going to pop up a little bit later in the course, along with a number of other higher level concepts. But you nailed it here. Okay, great. Let's do some more questions. Okay, let's try this guy. Yeah. All right, go ahead and read question 84 for us, please.
What are the solutions of the equation 0 equals 3x squared plus 2x minus 8?
Eek. Okay. This is a quadratic formula question. You know what I mean when I say quadratic formula?
Yes.
Yeah. For the vast majority of students I work with, I coach them to avoid the quadratic formula. Because even if you know how to do it, there's so many steps. And it gets really complicated. I just see students mess it up all the time. I mess it up all the time. Okay. There's just a much easier way to solve this. Much easier way to solve this. How can we test the answer choices here?
Substituting them for x?
Absolutely. Just plug them in, right? We have to get a true statement for the right answer choice. We have to. Okay. Now, this is a little bit tricky here because I'm looking at like all the answer choices and I've got fractions here, right? And negative fractions, right? That's a little bit annoying. It's going to make it difficult to do the arithmetic. But
is there a way to eliminate the fractions or no?
Well, I don't think we have to worry about them here because look at the second half of all the answer choices.
Oh.
Yes. Notice they're all different. They're all different. So if 2 gives us a true statement, it's got to be answer choice A. Right?
Okay.
The maximum number of solutions for a quadratic equation are going to be 2. You're not going to have 3 solutions for a quadratic equation. You're not going to have 4 or 5. If 2 works, it's A. If negative 2 works, it's B. If 8 works, it's C. If negative 8 works, it's D. Does that make sense?
Yes.
Yeah. This is much easier than it looks. We don't have to do the quadratic formula, and we don't even have to test the fractions. Okay. So let's start with answer choice A. We'll start with plugging in a 2. Let me see you work that out. good. Let's PEMDAS this puppy. Looking good, Karis. True statement?
No.
No. We can get rid of answer choice A. 2 doesn't work. So I don't care whether negative 4/3 does or not. Doesn't matter. 2 is not a solution. It can't be A. That's good enough here. Does that make sense?
Yes.
Okay, great. Let's go to answer choice B. Let's try negative 2. Excellent. Yep, it's going to be positive 4. If you wanted to simplify this here, right? I mean, you could figure out what 2 times negative 2 is, right?
Okay.
Yeah. What's that?
That would be negative 4.
Yeah, negative 4. Right. So we're subtracting 4 here. Minus 8. You don't have to do, when I say step by step, like you don't have to just do one chunk at a time. You know what I'm saying? Like you can kind of simplify as you go along, you know.
Okay.
What's that going to give us?
So we have 12 minus 4 minus 8, which that would equal 0.
That would equal 0. We get a true statement for negative 2. This is interesting. This is interesting. Okay. Now, take a look at the other answer choices here. Take a look at C and D. All right. We know negative 2 gives us a true statement. We know negative 2 is a solution. Do you see negative 2 in answer choice C or D?
No.
No. They can't be right. They can't be right. Now, if you did see negative 2 as a solution, like if this was instead of negative 1/3, it was negative 2, you would have to test 8 as well. Right? Does that make sense?
Yes.
You would have to. But because negative 2 doesn't pop up in any of the other answer choices, and we know negative 2 is a solution, I think we can stop right there. It's got to be answer choice B, and it is. Any questions about that?
Nope.
Don't abandon basic logic on a test like this. You can use it all the time to simplify things. All the time. Use it. Use it. If negative 2 is a solution, the others can't be right. Make sense?
Yes.
Awesome. 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 Let's do just a few more questions. Ooh. Go and read question number 91 for us, please.
Which points satisfy both of the following equations?
Ugh. All right, I mean, it's a system of equations here. There's an algebraic way to do it. I don't want to do it. Do you see how we can just test the answer choices here?
Substituting the points?
Yeah, absolutely.
Into the
Plug
equation?
Plug them in for x and y. The right answer has to give us a true statement for both sets of values and for both equations. Does that make sense?
Yes.
Okay. Now let's be a little strategic here. Let's be strategic. I see some bigger values in here, and there's some stuff with negatives, and I don't want to start there. Let's start with the easiest values to test. What do you think the easiest values to test are?
I would go with C.
Yeah, start with C. Start with 3 and 1, right? It's going to be easy. Start there. Let's test that. So these are ordered pairs, right? The x value is 3 and the y value is 1. So just plug in a 3 for x and a 1 for y.
Okay.
All right, let me see that. We'll start with the top equation. We'll see if that works. Okay, true statement?
Yes.
Yeah, it is. Try the bottom equation. True statement?
Nope.
Nope, answer choice C is gone. Any questions about that?
Nope.
Okay, great. Let's do the next set of easy values. What's the next easiest one?
Maybe A?
Maybe. I'd probably do 4 and 3.
Oh, okay.
I'd probably do that. Again, I mean, I'm tempted by D, doing 2 and negative 1, but negatives, if we can avoid the negatives, let's avoid the negatives. But let's try 4 and 3.
Okay.
True statement?
Yes.
Yeah. Try the bottom equation. True statement?
Also yes.
Also yes. Also yes. Okay. We got some options here. We can do the 2 and negative 9, or we can try to get rid of another one.
Which would be faster on a timed test?
Yeah.
Or is there not really like a way to predict that?
Well, I'm going to step back for a minute and kind of think about this logically here, right? These are, we've got 2 equations here. The top one is a line. Is that obvious? That's a line?
Yes.
Yeah, that's a line. The bottom one, that quadratic, right? X is raised to the power of 2. That's going to be a parabola. Is that clear?
Okay.
Yeah. What's the greatest number of solutions if we've got a line and a parabola?
It would be 2.
The greatest number of solutions is 2, right? I mean, it's possible here we've got like a parabola and a line. There could be no solution. That's a thing. They don't intersect, right? You see what I'm saying here?
Yes.
Yeah. And it's possible they could intersect in one place, right? If it's like a tangent line or something like that, like woo, something like that. There could be one solution. Okay. But I don't think there's any way to have more than 2 solutions. Right? I don't think so. So because I don't see 4, 3 in any of the other answer choices, I think it's really likely it's going to be B. Does that make sense?
Yes.
Because if 4, 3 works, you can't have 2 other independent solutions, giving you a total of 3 solutions. Right?
I see.
Yeah,
okay.
I think it's got to be B. Now let's double check. Let's confirm this. Let's plug in the negative 2 and negative 9 just to make sure. But I don't see how B is not going to work if 4, 3 works. Let's try it. Let's try negative 2 and negative 9 just to confirm it.
Okay.
Because even with the negatives, it's not too bad. All right, looking good. True statement.
Yep.
That works. Let's try the bottom equation. Well, that's looking good. True statement?
Yes.
Absolutely. There we go. We can confirm it. But I think technically we could have stopped there, right? At 4, 3. We could have stopped there. Does that make sense why?
Yes.
Yeah.
Okay.
Now, again, if there were a 4, 3 in the other answer choices, then, we got to test the other ones. But if 4, 3 works and the others don't have 4, 3, it couldn't be A or D there. They couldn't. You couldn't.
Okay. And for the sake of time on a test, we could just select
Absolutely.
that.
Absolutely.
Okay.
Absolutely. Absolutely. Any questions?
Nope.
Okay, great. Let's do one last question, and then we'll wrap it up. All right. Which one are we doing here? Aha. Did we do this one? No, we did not. All right. We'll wrap it up here with this one. Go and read question 111 for us, please.
Which of the following x, y, z is a solution to the system of equations below?
Okay, and then there's that mess of 3 equations. Oh, good heavens.
Yikes.
Okay, yeah, absolutely. I don't want to do the algebra here. Don't even think about it. They give us the answers. They give us one of those is going to give us a true statement for all those. So let's use that strategy that we used before. Let's just start with the easiest ones. Let's start with the easiest ones and just test these answer choices. What do you want to start with?
B.
I'd start with B as well. At least plug into the top equation. That's not going to be too complicated. So start there. Let's see what happens. Looking good. Again, these are ordered pairs here, except we got 3 of them, so it's X, Y, and Z values. Okay. Looking good. True statement?
Yep.
Absolutely true. Let's try the second equation. Oh, that's looking ugly. Let's stop for just a minute. Is that going to give us a true statement?
Probably not.
Probably not. Why not?
The 40, the left side of the equation is going to be much larger.
Yeah, it's going to be huge, right? This is going to be, I don't know exactly what that is, but it's going to be close to 0. I don't even know what the square root of 5 is. I don't know. I don't care, right? It's going to be a little bit bigger than 2, right? Because the square root of 4 is 2. Does that make sense?
Yes.
Yeah, but there's no way that's going to be true. So just stop there. And again, this is where you can use that estimation all throughout this test without having to calculate everything. It's going to save you a lot of time. I would just stop there. I would stop there. Get rid of answer choice B. Any questions about that?
Nope.
Okay. What's the next set of values we're going to test?
D.
Let's try D. Yeah, right. We're not dealing with fractions there. Makes sense. So plug in for answer choice D. Let's see it. Looking good. Real quick, hold on. The Y value. Okay, I see what you did here. Okay, good. You're good. You're good.
Okay.
You're good.
So what's the best way to solve the 5 times 16 like in your head without a calculator?
Great question. I love it. I love it. I would. I'm a big fan of I'm just such a huge fan of estimating. I know what 5 times 10 is, right?
Okay.
What's 5 times 10?
50.
50. And then we can just add 5 times 6 to 50. Right? What's 5 times 6?
30.
30. What's 50 plus 30?
80.
80. That works. That works. Does that make sense?
Okay. Yes.
Yeah.
It's way more simple than I thought it should be.
But you could stop right here, because is that going to give us a true statement?
Nope.
No way. No way is it going to work. No way. The answer choice D is gone. Right? It's just too big on the left-hand side. What next?
A.
Let's try A. Yeah, let's talk about this. Yeah, exactly. You did it beautifully. Let's talk about operations with fractions real quick. Right? That's 2 times 1 over 4. Right? Do you know how to do that? If I'm going to turn 2 into 2 over 1. Like this. Does that make sense why those two expressions are equal, this one and this one?
Yes.
Yeah. And you got it right. You absolutely. I'm just going to clarify for anybody watching the recording that doesn't know how to multiply fractions. When you're multiplying fractions, right, you multiply across the numerator and across the denominator. Multiply the numerators and multiply the denominators. Okay, it's different from when you're adding and subtracting fractions. We'll see that a little bit later throughout the course, operations with fractions. But that gives you 2 or 4. You can reduce that to 1/2, what you got. Does that make sense?
Yes.
Okay, just clarifying for anybody watching this that doesn't know how to multiply those terms together. Okay. That's not looking promising, is it?
Nope.
No, it's not. It doesn't work. It doesn't work. So it can't be answer choice A. I think we found the right answer.
So it would have to be C.
It has to be C. Because the others don't work. That's good enough for me. It's C. We can stop there. Especially on a time test. Stop there. Good enough. Doing untimed work and you want to practice these operations and all, you can test everything, great. You can practice your arithmetic. Probably a good idea. On a time test, getting rid of the wrong answers is as good as finding the right one. Does that make sense?
Yes.
Good. Any questions at the moment?
Nope.
Okay. Let's wrap it up there. Karis, you've been awesome today. I cannot thank you enough. You've been just a perfect student. So thank you. Thank you very much. And you asked great questions today. I'm going to get you access to these problem sets, okay? And a couple new questions. They're all plugging in values questions that you're going to need access to. If you're watching the recording and taking the course, you'll have access to this as well. It's important that you practice this. Practice using these strategies that I'm teaching you. I'm a big fan of repetition. It just works. So I want you to practice these questions that we worked on today, and then just like 3 other questions, maybe. Just a couple other questions, new ones. If you don't know how to solve the new ones, don't worry about it. We're going to go over those at the beginning of the day 3 section of the course. Okay, so don't beat yourself up over it if you're struggling with those new questions, but they're all plugging in values questions. Does that make sense?
Yes.
Okay, good. So go ahead and work that out before I see you next. And if you're watching the recording, work these out as well. Make sure that you've got these strategies down. Make sure you've got your arithmetic down. You just need to have arithmetic for this test. Much more so than the algebra. Much more so, as you can see from all these questions. So, okay. Do you have any questions for me, Karis?
Nope, I don't.
Okay, awesome. You've been wonderful. Thank you so much. And I'll look forward to seeing you next week. We'll work on some more of these plugging in values questions and some more specific concepts that they test on the CLT as well. But we'll cover it all. Everything you need to get a good score increase. Okay?
Okay, perfect.
Thank you, Karis. You've been wonderful. I look forward to seeing you soon, okay?
Okay, thank you.